Hello everyone, welcome to our channel Everyday Learning. So in today's video of digital logic design, we are going to understand what is a 7-segment decoder, or it is also popularly known as a 7-segment display. And this 7-segment display or 7-segment decoder is used extensively in hardware designing to display a particular output. Basically, it is used to display the decimal digits or any kind of representations. And practical examples of 7-segment decoders are like digital clocks that have red LEDs or cathodes on the display, and you can see it mostly visualizing time or anything like that. So let us understand how it works. So you see this is divided into 7 parts and it contains 7 cathode displays, and there are different pins, and whenever the pins are connected, and the pins can have a circuit design in the back end which will enable the 7-segment display to produce output or sequences according to the sequence provided. Now you see I have designed this table which will show the output 0 to 9 on the 7-segment decoder or 7-segment display, and I will provide 4 BCD inputs. So as the sequence of the BCD inputs changes, the output of the 7-segment decoder will also change. So if we see, this one is A, B, C, D, E, F. So if we want to display 0, all we need to do is do something like this. So if we match it with this one, the cathode of G will be turned off, the light of the stripe G will be turned off, and the other ones will be turned on. In this sequence, if we can see number 1 is like this. So the light will be on only for B and C, and the others will be turned off. So you can see here that B and C has value 1 and the others are 0. In this sequence, we have did for all the sequences up to 9. If you can see here in 9, for 9 only F will be turned off because 9 is somewhat kind of like this. So only this one is turned off and all others are turned on. So this is the table for the 7-segment display. You can understand it pretty well by observing the table. Now, how can we implement it using the 7-segment decoder? So you can see here that there are 7 sequences A, B, C, D, E, F, G, and we'll have to produce a function that is able to display 0. So let's see how can we do that. So I'll show in this video for A, and you will be able to understand the remaining ones afterwards. So let me go a bit down, and for A I'll need a K-map. So this one is the K-map template. I request you to don't miss the video on K-maps because that one is very important. So let's take for A, let me mark A here straight. Let me put on the values. So don't care. So these are the values. Now it's time for grouping. So we can see that we can do one group taking the 4 ones and the don't care from the 4 corners. We can take another group with these 4 pairs, and we can have another group here, and we have another group over here. So we have quite a number of groups in here. So if we do the simplification using the K-map, we'll find the logic sequence for A to be A plus C plus BD plus B0 D0. So we have used K-map simplification to get this sequence. Now using this sequence, If you implement it in a circuit, implement this function in a circuit, then you will be successfully able to represent this sequence with the help of the sequences that you get by solving k-maps for each of the segments. So if you have functions for like b, c, d, e, f, g, in this way you can display all the letters. You can even change the letters to display something else according to your wish. So all you need to do is just make a table like this, do the simplification and determine the logic sequence. Then it is a very easy task for you to use the 7-segment decoder or the 7-segment display and do the things that you require for your logical device. So I hope you are able to understand how to work on the 7-segment decoder or display. Feel free to write down below if you have any queries, and thank you for watching our video.